All right, 7th graders, welcome to the 3 chapters that are my ultimate favorite to teach students. We are starting with polynomials. It will lead into quadratics. And while it doesn't mean anything to you now, this is huge in future courses. You will use these 3 chapters more so than anything else you learn this year in future courses. So in this section, you're going to learn how to add and subtract polynomials, also by finding their degrees, classify them, and solving in real-life problems. All right, let's talk about how do we find the degrees of a monomial. First thing we need to look at is what is a monomial. A monomial is a number, which could be like 5. A variable, which could be x. Or the product of numbers and variables. So this could be 3a squared b. 5 represents your number or your constant, x represents your variable or your letter, and 3a squared b represents the product of a number or one or more variables with whole number exponents. Now here's the easy part. The degree of a monomial is just the sum of the exponents of all the variables. The degree of a non-zero constant, that means, for example, 7, has the degree of 0, and the constant 0 has nothing. Let's look at all of these examples in your chart. Here are 4 monomials. 10 is just a constant. It has a degree of 0. 3x, well, x has a power right here of 1, so your degree is 1. Now in this next one, a has a power of 1, b has a power of 2, so we add them together. We find the sum, so your degree is 3. And in the last one, the degree is just 5. So let's go over things that are not monomials. 5 plus x. Well, 5 is a monomial and x is a monomial, so that's 2. So that's just the sum of 2 monomials, which is not a monomial. 2 divided by n. Both of these are monomials, so therefore this is not a monomial. A monomial cannot have a variable as an exponent, and a variable must have a whole number exponent. So these would be examples of not monomials. So let's start with our first really super easy example. We're going to find the degree of each monomial. So in A, since we only have one variable, the power to that is 2, my degree is 2. In B, I have an x and a y, so the x has an exponent of 1. So I add that to the variable 3's power, so 1 plus 3 gives me 4. Here I have 3 and 3, you add them together, you're going to get a degree of 6. And lastly, it's just a constant, so that has a degree of 0. Classifying polynomials. So now we're going to actually use our core concept of classifying polynomials. Now first, what is a polynomial? All a polynomial is a monomial or a sum of all monomials. So if I had 2 monomials, that would be a binomial because that's 2. If I had a polynomial with 3 terms, that means trinomial. So this is an example of a binomial. This is an example of a trinomial. Now, the degree of a polynomial is the greatest degree of its terms. A polynomial in one variable is in standard form when the exponents, this is, by the way, something you're going to be using all the time, like every time. When you write a polynomial, you need to write it in standard form. Standard form means that your exponents go from highest to lowest. So the exponents decrease from left to right. When you write a polynomial in standard form, the coefficient is the first term called the leading coefficient. So let's look at this. This right here is a polynomial with 4 terms. Here's a monomial. This is important that you get this. Monomial, 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 monomial. You have 4 of them. Because the highest degree is 3, that means that the degree of this entire polynomial is 3. The leading coefficient is 2. The constant term is the number at the end. What I look at is this, standard form. The highest exponent here is 3. Then it's 2. Then it's 1. Then it's 0. Looking at each of these exponents, 3, 2, 1, 0. These are the degrees. So that's the order from highest to lowest. So in example 2, we're just going to write this in standard form. So looking at this polynomial, 15, whoops, I'm going to put an x, 15x minus x to the third plus 3. This is a trinomial. Once again, each of these represent a monomial. There are 3 of them, so it's a trinomial. When I ask you to put this in standard form, you need to put the highest exponent first, the next highest, and so on. Well, because 3 is the highest exponent, we would write negative x to the third plus 15x plus 3. That cannot be simplified because there are no like terms to combine together, and that would be your exponent. Or I'm sorry, that would be your answer. Negative x to the third plus 15x plus 3. If I gave you another one, 3x to the fourth minus x to the fifth plus 7 minus 3x minus 2x squared. If you would put this polynomial with 5 terms in standard form, you would get this. Highest power is the fifth power, so it'd be negative x to the fifth. Then plus 3x to the fourth. Then negative 2x squared. Then negative 3x, then plus 7. This polynomial is now written in standard form. The leading coefficient would be negative 1, and the degree would be 5. Now, if you looked at the degree of each of these, the degree of this is 5, 4, 2, 1, 0. Now, example 3. We're going to classify them. Write each polynomial in standard form, identify the degree, and classify each polynomial by the number of terms. Well, a is just one term. So in standard form, it would just be negative 3z to the fourth. The degree is what? 4. And this is just a monomial. Now in example 4, we have to put it in order from highest to lowest exponent. So that would be 5x squared would be our highest degree. Then minus x plus 4. The degree of this one is 2. And since there are 3 terms, it's a trinomial. Let me actually fix that. Trinomial. Lastly, this one would be q to the fifth plus 8q. The degree would be what? Good, it is 4. I'm just kidding, it's 5. The degree is 5, and this would be a binomial. Now, we are now going to learn how to add and subtract. Now, I'm just going to tell you right now, this is easy, really easy. You only can combine like terms. And as you already know, like terms are terms that have different coefficients. That's the only thing that can be different. The variable and the exponent have to be the same. So let's go over this entire thing. A set of numbers is closed under an operation when the operation performed on any 2 numbers in the set results in the number that is also used in the set. Now you're looking at this probably going, I have no clue what that even means. Okay? For example, the set of integers is closed under addition, subtraction, and multiplication. This means that if a and b are 2 integers, then a plus b, a minus b, and a times b are also integers. That's all it means. Is that anytime you take 2 integers and you add, subtract, or multiply them, your answer is also an integer. So the set of polynomials is closed under addition and subtraction. So the sum of any 2 polynomials is a polynomial. That's what it means. The sum of any two polynomials would also give you a polynomial, as will the difference. To add polynomials, all you do is just add like terms. I'm going to show you how to add vertically or horizontally, but honestly, most of this is done with no work. We're going to start with A. Now, in A, I'm just going to add like terms. Now, the only thing you must do is make sure it must be in standard form. Always, 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 always standard form. So we look at this. All I'm doing is combining like terms here. So I look at the highest exponent. The highest exponent is 3. So now I add 2x to the third plus 1x to the third, which gives me 3x to the third. Then I add my x squareds. So I have negative 5x squared plus 2x squared. That gives me negative 3x squared. The next term is plus x. There are no other plus x's. And then minus 1. So my polynomial is 3x to the third minus 3x squared plus x minus 1. Super easy. If you wanted to line them up, it would look like this. 2x to the third minus 5x squared plus x plus 2x squared. Then the plus x to the third goes here, and then minus 1. Make note that when there is a power of the variable that is missing, you leave that blank or you put a 0 here. It's up to you. And then you just add them up and down vertically to look like that. If you wanted to add them vertically, you can, but I very rarely ever see anyone do this because it requires work, and this is definitely just as easy. So now I want you to solve B by yourself. You may pause the video and do it yourself. If you did it correctly, 4x squared plus 5x plus 4 would be your answer. Subtraction is just as easy. The only thing you have to make note of is this. When you are subtracting a polynomial, you are subtracting all of these terms, which means you have to distribute a negative 1. So as you write it onto your paper from the book, you're more than welcome to just, rather than copying the problem, go ahead and start distributing. Negative times negative 2n squared is plus 2n squared minus 2n plus 4. I distributed into the polynomial I was subtracting. I now combine like terms in standard form, and my answer would be 6n squared. Then the minus 2n plus 5 plus 4 gives me plus 9. If you did it vertically, you would do 4n squared. Since the n term is missing, you could put plus 0n plus 5 minus, and then line up your like terms. And you would eventually have to distribute and get the same answer. So it's up to you if you want to do it horizontally or vertically. So go ahead and pause the video, do B on your own, and see if you get it right. If you did it correctly, you should get x squared minus 2x plus 13. Now let the fun begin. This is where we take quadratics, and you don't know what you're doing. You don't know you're doing quadratics yet, but this is what you're doing. Anytime you throw an object up, down, there is a set quadratic formula that you're using, which you don't know yet, but I'm just letting you know this is eventually what we're getting to. So in example 6, our last example, a penny is thrown straight down at a height of 200 feet. At the same time, a paintbrush is dropped. Notice the difference. This penny is thrown. The paintbrush is only dropped. From a height of 100 feet. The polynomials represent the heights in feet of the object after t seconds. So this entire polynomial represents the height of the object after t seconds. And the same thing with this one. So in A, we want to write a polynomial that represents the distance between the penny and the paintbrush. Since we want to know the distance between, we subtract them. So this would just be negative 16t squared minus 40t plus 200 minus, and you must, when you subtract more than one term, you must have parentheses. So please make sure parentheses are written down, or parentheses, how I sometimes call them. So that would be negative 16t squared plus 100. I now distribute the negative. That gives me negative 16t squared minus 40t plus 200 plus 16t squared minus 100. The 16 and negative 16t squared cancel, so I am left with negative 40t plus 100 would be the distance between them. So now, I love this part, interpret the coefficients. So what does that mean? It means what does the negative 40 stand for, and what does the 100 stand for? Here's what it means. There's a lot here. When t is 0, this is important. When t is 0, the paintbrush is 100 feet. So when t is 0, the penny is 200 feet. So the constant term here for 100 represents the distance between the penny and the paintbrush when they begin to fall, right here. That 100 means the distance between them is currently 100 feet. As time goes on, the distance between them for every 1 second will decrease by 40 feet. That means the objects become 40 feet closer to each other each second. So negative 40 represents the amount that the distance between the object changes each second.